Hello my lovely students, you are welcome to a new lesson. Today, I shall be teaching you coordinate geometry of straight lines part 2. From definition, coordinates are two numbers which give the position of a point on a Cartesian plane or graph, showing a plane surface with two axes, that is the x coordinate and the y coordinate. Also, geometry is the study of the properties of shapes, such as lines and angles. A straight line is a line which goes in the same direction. Let's learn more about coordinate geometry of straight lines. In today's class, we are going to learn about number 1, angle of slope, number 2, angle between two straight lines, number 3, condition for parallelism and perpendicularity, and number 4, equations of a straight line. Number 1, angle of slope. If theta is the angle of slope, that is the angle between the straight line and the horizontal, which is the x-axis, and m is the gradient or slope of the straight line, then the formula for the gradient is the change in y divided by the change in x. The formula for the gradient m is equal to tan theta, which is the angle of slope, while the formula for the angle of slope theta is equal to the tangent inverse of m, which is the gradient or slope. Please take note of these formulas. Number 2, angle between two straight lines. If alpha is the angle between two straight lines of gradient or slopes m1 and m2, then the tangent of alpha is equal to m2 minus m1 divided by 1 plus m2 m1. While alpha, which represents the angle between the two straight lines, is equal to the tangent inverse of m2 minus m1 divided by 1 plus m2 m1. Once again, please take note of these formulas. Number 3, Roman figure 1, condition for parallelism. From definition, parallel lines are straight lines which are the same distance apart at every point and will not intersect when produced or extended. Parallel lines are represented with arrow heads. If two straight lines of gradients or slopes m1 and m2 are parallel, then the gradients or the slopes are equal. That means m1 is equal to m2. Hence, when lines are parallel, their gradients or slopes are equal. Parallel lines have the same gradient or slope. Please take note of this condition for parallelism. Number 3, Roman figure 2, condition for perpendicularity. From definition, perpendicular lines are straight lines which intersect at right angles or 90 degrees. If two straight lines of gradients or slopes m1 and m2 are perpendicular, then we have three formulas. Number 1, m1 times m2 is equal to minus 1. Number 2, m1 is equal to minus 1 divided by m2. And number 3, m2 is equal to minus 1 divided by m1. Hence, when lines are perpendicular, the product of their gradients or slopes is minus 1. Please take note of this condition for perpendicularity. Number 4, equations of a straight line. The equations of a straight line passing through the points x1, y1 and x2, y2 with gradient or slope m and y-intercept C are as follows. The first equation of the straight line is y is equal to mx plus c. The second equation of a straight line is y minus y1 is equal to m into x minus x1. The third equation of a straight line is y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1. Please take note that of these three equations of a straight line, equation 1 is the general equation of a straight line, while equations 2 and 3 are other forms of the general equation of a straight line. Once again, please take note of all these formulas. Next, let's see some examples on coordinate geometry of straight lines. Our first example is on angle of slope. Example 1. Roman figure 1. Find the gradient of the straight line joining the points 3, 2 and 7, 10. Roman figure 2. Find the angle of slope of the straight line. Let's see the solution to question 1, Roman figure 1. From the question, let the point 3, 2 be our point 1. That means that x1 is equal to 3 and y1 is equal to 2. Also, let the point 7, 10 be our point 2. That means x2 is equal to 7 and y2 is equal to 10. Next, can you state the formula for the gradient of the straight line? Let's see if you can. The gradient of the straight line is y2 minus y1 divided by x2 minus x1. I hope you got that right. Next, if you substitute your values for x1, y1 and x2, y2 into your formula for gradient, what will be the gradient of the straight line joining the 2 points? Let's see if you are right. When you substitute your values for x1, y1 and x2, y2 into your formula for gradient, the gradient becomes 10 minus 2 divided by 7 minus 3, which will give us 8 divided by 4. The gradient of the straight line is 2. I hope you got that right. Next, let's see the solution to question 1, Roman figure 2. Can you still remember the formula for the angle of slope of a straight line? Let's see if you can. The angle of slope of a straight line theta is equal to the tangent inverse of m, where m is the gradient or slope. I hope you got that right. In this question, the gradient or slope is 2. When you substitute 2 for m into our formula for angle of slope, what will be the angle of slope of the straight line in question 1? Let's see if you are right. Our angle of slope theta is equal to the tangent inverse of 2. That gives the angle of slope as 63.43 degrees. I hope you got that right. Please take note of the solutions to example 1. Let's see our second example involving angle between two straight lines. Example 2. Calculate the angle between the straight lines y is equal to 4x minus 7 and x minus 2y plus 1 is equal to 0. Let's see the solution to question 2. The general equation of a straight line is y is equal to mx plus c. Here m represents the gradient or the slope of the straight line. Comparing the first equation, y is equal to 4x minus 7, with the general equation of a straight line, what will be the gradient or slope of the first straight line? Let's see if you are right. The gradient or slope of the first straight line, m1, is equal to 4, which is the coefficient of x in the equation. I hope you got that right. Secondly, let's rearrange our second equation, which is x minus 2y plus 1 is equal to 0, by making y the subject of the equation. When we do this, we are going to have the equation as y is equal to 1 over 2x plus 1 over 2. Now, comparing this rearranged equation with the general equation of a straight line, what will be the gradient or slope of the second straight line? Let's see if you are right. The gradient or slope of the second straight line is m2 is equal to 1 over 2, which is the coefficient of x. I hope you got that right again. Next, can you tell the formula for the angle alpha between the two straight lines having gradients m1 and m2? Let's see if you can. The angle alpha between the straight lines is alpha is equal to the tangent inverse of m2 minus m1 divided by 1 plus m2 m1. I hope you got that right. Next, let's substitute the values m1 is equal to 4 and m2 is equal to half into our formula for the angle between the two straight lines. When we do this, we are going to have the angle alpha between the two straight lines as the tangent inverse of minus 1.167. Please take note that the negative sign in minus 1.167 represents an obtuse angle. Let's see the way we can deal with this condition. Firstly, let's consider the acute angle between the two straight lines. In doing this, we are going to disregard the initial negative sign in minus 1.167 and we are going to solve for alpha is equal to the tangent inverse of 1.167. When we do this, what will be the acute angle alpha between the two straight lines? Let's see if you are right. The acute angle alpha between the two straight lines is 49.4 degrees. Next, the obtuse angle between the two straight lines can be obtained by 180 degrees minus the acute angle alpha. That gives us 180 degrees minus 49.4 degrees. That gives us an obtuse angle which is 130.6 degrees. Please take note of these solutions to example 2. Let's see our third example for condition for parallelism and perpendicularity. Example 3. Determine if the following straight lines are parallel or perpendicular. The straight lines are y is equal to 2x minus 1 and 2y plus x is equal to 2. Let's see the solution to example 3. The general equation of a straight line is y is equal to mx plus c. Firstly, let's compare the first equation, which is y is equal to 2x minus 1, with the general equation of a straight line. When we do this, what will be the gradient or slope of the first straight line? Let's see if you are right. The gradient or slope of the first straight line, which is m1, is equal to 2. This represents the coefficient of x in the equation. I hope you got that right. Next, let's rearrange our second equation, which is 2y plus x is equal to 2, by making y the subject of the equation. When we do this, we are going to have y is equal to minus 1 over 2x plus 1. When you compare this rearranged equation with the general equation of a straight line, what will be the gradient or slope of the second straight line? Let's see if you are right again. The gradient or slope of the second straight line is m2 is equal to minus 1 over 2. This represents the coefficient of x in the rearranged equation. I hope you got that right. Next, can you remember the condition for parallelism? Let's see if you can. To determine parallelism, m1 should be equal to m2. That means that the gradients should be the same or equal. But m1 is equal to 2 and m2 is equal to minus 1 over 2. And these gradients are not equal. Hence, the straight lines are not parallel. Next, can you remember the condition for perpendicularity? Let's see if you can. To determine perpendicularity, m1 times m2 should be equal to minus 1. Here, m1 is equal to 2 and m2 is equal to minus 1 over 2. When you multiply m1 and m2, of course, you are going to have minus 1. In other words, the product of the gradients is equal to minus 1. Hence, the straight lines in example 3 are perpendicular. Please take note of these solutions to example 3. Next, let's see our fourth example for condition for parallelism and perpendicularity. Example 4. Determine if AB is parallel or perpendicular to PQ, given that Roman figure 1, the coordinates of point A are 3 and minus 2, and the coordinates of point B are 2 and 1. Roman figure 2, the coordinates of point P are 5 and 7, and the coordinates of point Q are 6 and 4. Let's see the solution to example 4. In line AB, let point A be our point 1. That means that x1 is equal to 3 and y1 is equal to minus 2. Also, let point B be our point 2. That means that x2 is equal to 2 and y2 is equal to 1. Next, can you remember the formula for the gradient of a straight line joining the points x1, y1 and x2, y2? Let's see if you can. The gradient of the first straight line m1 is equal to y2 minus y1 over x2 minus x1. I hope you got that right. Next, let's substitute our values for x1, y1 and x2, y2 into our gradient formula to find the gradient of the line AB. Substituting values and calculating, the gradient of AB, which is m1, is equal to minus 3. Next, let's calculate the gradient of line PQ. In line PQ, let point P be our point 1. That means x1 is equal to 5 and y1 is equal to 7. Also, let point Q be our point 2. That means x2 is equal to 6 and y2 is equal to 4. Once again, what's the formula for the gradient of a straight line joining the points x1, y1 and x2, y2? Let's see. The gradient of the second straight line, M2, remains y2 minus y1 divided by x2 minus x1. When you substitute your values into this gradient formula, what will be the gradient of the second line, PQ? Let's see your result. When you substitute and calculate, the gradient of the second line, PQ, which is M2, is equal to minus 3. I hope you got that right again. Now that we know the values for M1 and M2, which are the gradients of the two straight lines AB and PQ, let's determine if the two lines are parallel or perpendicular. To determine parallelism, M1 should be equal to M2. Since M1 is equal to minus 3 and M2 is equal to minus 3, the two gradients are equal. In other words, line AB is parallel to line PQ. To determine perpendicularity, M1 times M2 should be equal to minus 1. We can see that if M1 is minus 3 and M2 is minus 3, multiplying M1 and M2 will give us 9, which is not equal to minus 1. In other words, the line AB is not perpendicular to line PQ. I hope the solution to example 4 is clear to you. Next, let's see our fifth example involving equations of a straight line. Example 5. A straight line cuts the x-axis at P and the y-axis at R. The gradient of the line RP is minus 3 over 2 and the line passes through the points x is 2 and y is 3. Find question A, the equation of the line RP, and question B, the intercept on the y-axis. Let's see the solution to question 5A. From the question, the gradient of the line RP, which is M, is equal to minus 3 over 2. Also, we are given a point 2 and 3. That means x1 is equal to 2 and y1 is equal to 3. From the question, which equation of a straight line will be required here, which should involve the gradient M and the given points x1 and y1? Let's see if you are right. The equation of the straight line required here is y minus y1 is equal to m into x minus x1. I hope you got that right. When you substitute your values for m, x1 and y1 into the equation of the straight line given here, what will be the equation of the line RP? Let's see if you are right. Substituting your values, m is equal to minus 3 over 2, x1 is equal to 2 and y1 is equal to 3 into the equation of a straight line, which is y minus y1 is equal to m into x minus x1. The equation of the line RP is 2y plus 3x is equal to 12. Please take note of all the steps required in getting this answer. Next, let's see the solution to question 5B involving the intercept on the y-axis. The general equation of a straight line is y is equal to mx plus c. When we rearrange the equation of the line RP, which is 2y plus 3x is equal to 12, by making y the subject of the equation, we are going to get y is equal to minus 3 over 2x plus 6. Once again, from the general equation of a straight line, which is y is equal to mx plus c, the c represents the intercept on the y-axis. When you compare the rearranged equation with the general equation of a straight line, you are going to find out that c is equal to 6, which is the constant term. Since x is equal to 0 on the y-axis, the intercept on the y-axis is x is 0 and y is 6. I hope the solution to example 5b is clear to you. Let's see our final example for equations of a straight line. Example 6. Given a point T with coordinates -2 and 7 and point W with coordinates 3 and 2, find the equation of the straight line connecting T and W. Let's see the solution to example 6. Let point T be our point 1. That means x1 is equal to -2 and y1 is equal to 7. Also, let point W be our point 2. That means x2 is equal to 3 and y2 is equal to 2. Can you remember the equation of a straight line which involves the 2 points x1, y1 and x2, y2? Let's see if you can. The equation of the straight line required here is y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1. I hope you got that right. Next, let's substitute our values for x1, y1 and x2, y2 into our equation of a straight line to find the equation of the straight line connecting T and W. Substituting your values into the equation of the straight line, you are going to have y minus 7 is equal to -5 over 3 plus 2 into x plus 2. When you simplify this further, what will be the equation of the straight line connecting T and W? Let's see if you're right. Simplifying your calculation, the equation of the straight line connecting T and W is y is equal to -x plus 5. I hope you got that right. Please take note of the solutions to all the examples involving coordinate geometry of straight lines. Thank you very much for going through the lesson today. I want to advise that for you to get more information about the topic coordinate geometry of straight lines, please continue to read your textbook. Don't forget to attempt your quiz and your assignment. I hope to see you again in our next class. Until then, it is goodbye for now. Thank you very much.